Hello SGD, Sacred Geometry Decoded, and I want to have a look at the transfer of knowledge from Egypt, but also the Sumerians, Chaldeans, Babylonians, depending on what time period. But especially this very important center, the Temple of Ra-Atum, or Heliopolis, the mound upon which it was built, this creation point, but especially later the connections to ancient Egyptian sciences and how this was a crucial transfer point from the more ancient world, Egypt, to other societies, the Greeks and Romans, especially because they left such thorough records in regards to this. So, the Ben Mound there, the high priest of Heliopolis, the chief of the observers, the high priest of Heliopolis was essentially the astronomer royal, and this being a center of science. So the astronomical connections, for instance, to the Great Pyramid is very clear. And where was the center of astronomy? It was at Heliopolis, that high priest there. Now, for instance, the polymath, the original polymath, you might say, Imhotep, the sculptor, the builder, the astronomer, the physician, so important that he was included on statues of Joseph, mentioned how important he was. He was of a rare group. He was the first of these commoner Egyptians to be elevated to a godlike status. Later periods in Egyptian history, he would be essentially called Thoth, connected to him, because writing the sciences, essentially architecture, was a field dedicated to Thoth, and Imhotep being the bee's knees in regards to this. And well, he was the high priest of Heliopolis, also making him the great seer, or the chief of the observers, the astronomer royal. Now, in previous videos, I'll add this to the Heliopolis playlist, Strabo's geometry, but other writers as well, mention the importance of Heliopolis. The priests in ancient times of settlement, priests who studied philosophy and astronomy, they excelled in their knowledge of the heavenly bodies. However, these men did teach, so they were a mystery school. They were very secretive, but people in centuries prior to Strabo travelled to Egypt. So Pythagoras, Plato, these greats of Greek science were either travelled to, or said to have travelled to, or were instructed by people who had travelled to and who had translated the Heliopolitan works and transmitted them to Greek, and allowing this flourishing of culture and science that the Greco-Roman world excelled at. But where was the origin point of this? Well, as Strabo and others point out, that they taught the Romans the year. So the Romans adopted the Egyptian year and their calendar system. We have the leap year, but they had a similar calendar system to keep the solar year in check, because they knew that it was 365 days and a portion, and this was unknown to the Greeks. Later astrologers who learned from the men who translated into Greek the records of the priests of Heliopolis, and even to this day they learn their teachings, and likewise those of the Chaldeans. So in the next 2 centuries following Strabo, Roman science and technology, they were on the verge of an industrial revolution. Astronomy, geometry, and time being some of the recorded, the most important things that the Greeks and Romans learnt from the priests there at Heliopolis. Herodotus praises the priests of Heliopolis in much the same way. And so, for instance, and I visited Thebes and Heliopolis for this very purpose, because I desired to know if the people of those places would tell me the same tale as the priests of Memphis. So Thebes, Karnak, Luxor, which was another in Lower Egypt, that was a center of astronomy, record keeping, and the sciences. The priests there were right at the very top of the social strata. For people of Heliopolis are said to be the most learned of the Egyptians, because it was there was the side of keeping of royal records, astronomical records, because that was where the observatory, the chief of the observers was. And again, he mentions that the calendar system, for the men reckoned by years and made the year to consist of 12 divisions of the seasons. Now I might touch quickly on Manetho. He was either a priest or the high priest at Heliopolis during the Ptolemaic period. He wrote down a history of Egypt for the Greeks, which said that Egyptian history goes back 13,000 years. There have been all sorts of attempts to say that, when he meant years, he was actually talking about months, and therefore we can fit it into the chronology. But as the Greeks and Romans learnt, that the priests at Heliopolis understood the year very well. And so when Manetho talks about years, it's more, it's really stretching things to say it's a month, but they, as Herodotus points out here, the 12 months times 30 days plus 5 days and above the number, so that the complete circle of seasons is made to agree with the calendar. And also, so the 365 and apportions days. Now we have the leap year, but they had a similar system of keeping it in check, which fell in and out of place. It's a very complicated matter, the calendar system, but it's also because, for instance, in Babylonian period, there was the royal measure and there was the common measure, and that would apply to calendars. But we can see the flood seasons, they wanted to time it to the rising of Sirius and kept that in check, so that the important rising would keep check with the calendar. And also Herodotus points out, he mentioned this is another Sesostris, but the land measure, to find out the measure of a piece of land, how much taxation would pay, speaking about the 3-4-5 triangle that the rope stretchers use to measure land and measure right angles. It's not generally accepted that the Egyptians understood the principles of Pythagorean theorem, but giving everything else, and we'll see in a moment. But also he mentions, as for touching the sundial and gnomon and the 12 divisions of the day, 12 hours of the day, again we'll look at that shortly, and they were learnt by the Hellenes from the Babylonians. So both Strabo and Herodotus point out that both the Egyptians, but also the Babylonians or Chaldeans or Sumerians, taught the Greeks and the Romans their calendar systems and also many other things, astronomy, geometry, and timekeeping. So Chaldea, also Sumer or Babylon, are the civilizations on the Tigris-Euphrates Valley, and we have the Egyptians on the Nile Valley. Any civilization that lasts a long time is on a river valley, because if you live on the coastline, eventually it's not good for you, not in the long run. So that's why these civilizations, the exceptions might be the Mayans, but they had the cenotes, they could get their fresh water from there. So although technically not on a river valley, they did extract their fresh water inland on the cenote system. So again, that's another example that coastal people, not so good for the long run. But how did this knowledge transfer from Egypt and the Chaldeans or Babylonians through to Greece and Rome? Well, geometry, the 3-4-5 triangle of the rope stretches. So a 3-4-5 triangle, if you mark out your rope like that and stretch it, you're going to get a 90-degree right angle. Now that's about the length that credit will be given to the Egyptians. It won't be not generally accepted that they understood the important geometry of the 3-4-5 triangle, the first of the Pythagorean triplets. That's the a squared plus b squared equals c squared. But Rhind Papyrus, 1650 BC, it's interesting because in the opening statements, a thorough study of all things, an insight into all that exists, knowledge of all obscure secrets. Very much in the vein of the Pythagorean schools, no one ignorant of geometry may enter my door, all is number, and that the importance, and it's still relevant today because all hard sciences are built around math and geometry. Without those, you cannot really do astronomy, you cannot do engineering, you cannot do these other important, even it applies to chemistry and others. All is geometry, all is number. This is the foundation stone of sciences, and because it's also so important to logic, which can be extended to philosophy as well. And so Plato was a great philosopher, but he was also a geometrician. The same concept of the trivium, so logic being so important to development of not just scientific systems, but also legal systems. And that by observing nature, you can find consistent patterns, and very important bit of knowledge. Now, where else? So the 3-4-5 triangle was not just for 90 degrees, because we'll see the importance of it in the Great Pyramid. King's Chamber is a 3-4-5 triangle. Khafre's Pyramid is based on a 3-4-5 triangle, or the Vesica, another beautiful piece of geometry. And the Amenet-Kamau Pyramid, which also is aligned. So Khafre and Great Pyramid, they align to Heliopolis. Amenet-Kamau and the Black Pyramid aligns to Heliopolis, based on the surviving stones. It's been dismantled, but based on the angle of the surviving stones, it points to an angle which would make it a 3-4-5 triangle. So this geometric knowledge from Egypt, as the geometric knowledge of Egypt to Greece and Rome, as described by Greco-Roman writers who travelled there and were very interested, especially in Heliopolis, but also in the Babylonian, Chaldean, and includes Sumerian geometry, very advanced. Plimpton 332, which has a list of the Pythagorean triplets, and also YBC 7289, which has the square root of 2 to about 7 or 8 decimal places of accuracy. Very, very high, very important sets of knowledge to the foundation stones of what we now call science. But so the 3-4-5 triangle, at least 1800 BC, at least 2500 BC in Egypt. But again, the standard history is that it wasn't understood before Pythagorean times. Not the principle that a squared plus b squared equals c squared. However, you can find this same important geometry in ancient temple complexes and megalithic sites such as Karnak in France, stone circles in England, and well elsewhere. And why would in these other places they're not just doing it for rope stretching the erosion on the river? It's a very important piece of fundamental. Astronomy was also imported from Egypt and Babylonians and Chaldeans. Babylonian astronomy was really advanced, very advanced. The synodic month, the full moon of 29.53 days, they had it to a level of accuracy to within a couple of minutes, and they achieved a similar level of accuracy in determining the true length of the year, 365.242 days. And this was centuries again before Hellenistic Greece. So geometry and astronomy, they tell us clearly that's where they got it from, but also the calendar systems. Again, the 365.24 days brought in from Egypt, but also the Babylonians to extraordinary high level of accuracy, but also the zodiac, the 12, not just the 12 months, the 12 hours of the days, but also the constellations. That was the zodiac, the one we in the newspaper astrology page. You look up your sign. These are the signs introduced from Babylon to Greece and then on to Rome. But they also taught the Greeks and the Romans about timekeeping, the 12 hours of the day, and Egyptian sundials divided the day into 12 hours, which is interesting because the Egyptian number system was not base 12. It was very much like Roman numerals, base 10, so was the Sumerian Babylonian system, but they had to 10 and then you would start repeating again. But this base 60 system, so where you count it in not hundreds or thousands, but in groups of 60, well, each hour, 12 hours per day, each hour is 60 minutes, each minute is 60 seconds. The 360-degree compass can be extended to this as well. But this is the maths, the astronomy, the geometry, calendar systems, timekeeping systems, and we'll get into more in other episodes, but also measure systems. That's a very important point as well. Measure systems are another very important feature imported from the ancient world. So Here we have 12 inches is a foot. Now, one of the beauties of this, well, 12 inches, the Romans and Greeks divided their units up into 12, and one of the reasons for that is because you can divide that into quarters and into thirds very easily. So 4 inches is 1/3 of a foot, 3 inches is 1/4 of a foot. That doesn't work so well in the metric system. So if you divide 1 meter by 3, you get 33.33333 centimeters. And that's the reason why you'll often find standardized, for instance, timber will often be sold in 1.2 meter lengths, so that it can be divided into thirds and quarters. So although it's technically metric, they're still employing this base 12 system rather than just selling it in 1 meter lengths. It's 1.2 or a variation of those to allow for the divisions into third and quarters. Now that fits in well, especially with the base 60 system, because that's effectively 12 times 5. And that also applies with ancient units of measure as well. But weights and measure systems, and how were they imported? Well, now I've done lots of videos on pendulums and cubits and meters and feet and the connections, but there's a very strong connection between these systems. But let's look at weight, for instance. So the Greek ounce, this is from Egypt, but the Ptolemaic period, the Greek Ptolemaic period, or the Greek rulers of Egypt since Alexander, and they used 27.3 grams for an untia or an ounce, and the Romans adopted that as well, 27.3 grams for an ounce. Now if you look at Roman ounces, you might be easily confused because that's an actual ounce in Rome itself. In provinces, essentially the further you got away from Rome, the more an ounce weighed, and that's taxation issues and how the money would be funneled back into Rome. But a Roman ounce was equal to a Greek ounce, which was equal to 1 Egyptian copper deben, 27.3 grams. Half of that, 13.66 grams, was a gold deben, but the Egyptians weren't using coins, but they were using precious metals, including copper, as money. And that's one of the reasons why Egyptian workers would have their copper chisels weighed at the beginning, at the end of each day, so that they did not shave bits of copper off. And then you could shave a little bit off, and you would add it, because 1 copper deben was well, you could buy a standard size grain, and you could feed your family for quite some time, maybe a month. I'm not exactly sure, not in memory at the moment, but this was an important measure system, but also the use of copper being so important. Now, why did Egyptian workers have their chisels weighed at the beginning and end of each day? The same theme. If you just look up old coins, you'll often find that you might that the coins are actually they lose size, and what that's called chipping, and what people would do even up until recent times. For instance, the tavern keeper would get a silver coin, he would chip a bit off, store it away, and then the next coin come through, he would chip a little bit off, and then he could add up those pieces and make another coin out of it. Because you just go to the coin maker, he would stamp it for you, and away you go. So that's why chisels were measured in the old days, and that's why you'll often see coins that have been shrunk down in size because they've been shaved or chipped. But the 27.3 gram system, half of that, 13.66, used in ancient Egypt, and this just happened, this is Old Kingdom, mind you, and that just happens to match the Mohenjo-Daro system of weights as well. 13.6, 27.3, half of 13.6 is 6.8, and that ties in beautifully with the Minoan systems as well as the old Babylonian systems as well. So for instance, 680 grams, 6.8 times 100 was a mina. So you have these stone weights found in the Mesopotamian area 680 grams. So weights and measure systems also, so along with geometry, astronomy, calendar systems, timekeeping systems, have their genesis in Egypt or Chaldea, Babylon / Sumeria. So this is part of the knowledge that was transferred from the ancient world. weights, measures, timekeeping, divisions of the day, but also divisions of the year, astronomy and geometry, these all blending into one another. But that brings us now to technology, and this is still like a bit of a bugbear for me, because if you mention this transfer of knowledge, immediately, at least certain circles are immediately accepted that yes, of course, they come from earlier streams of knowledge. But when it comes to technology, the Romans and the Greeks recorded the origins of their geometry, astronomy, calendars, time, and we can see it corresponding in weights and measure systems as well. But when it comes to technology, there's a bit of a barrier there. And so the obelisks of Egypt, how were they moved? How did they not move and lift these items? Well, this is where there is a certain resistance amongst this. Now, the Romans moved massive obelisks from Egypt, including the Lateran obelisk, originally 450 tons, now 330. It was moved in 1558, but 357 AD, this was one of the largest, if not the heaviest, of the Egyptian moved obelisks. Doesn't include the unfinished one, but that was unfinished. But the same technology would still apply, you just have to scale it up. And so, fantastic achievement. So for instance, from Aswan, they would move the stone, essentially the whole length of the Nile. Huge distance. But that was along the river, so it was only a short distance from the quarry to the river, and then up the river, and then a short distance to the final site, whether it was Karnak or Memphis or the Giza Plateau, Heliopolis. Yet, the Romans moved obelisks, not just up the Nile, but they moved them across the Mediterranean, across the sea, and then they moved them 27 kilometers inland up this very, very rugged terrain to bring them to Rome. So massively, they outdid the Egyptians hugely. But how did they learn to do this? Now, they inherited so much of this other knowledge from previous civilizations, yet there's a bit of a block not to acknowledge the fact that the Romans learnt their technology from earlier civilizations. And unlike Strabo and Herodotus, who clearly say that that the Egyptians, Romans and Greeks learn it from Babylonians and Egyptians when it comes to the philosophical sciences, astronomy, geometry, calendars, timekeeping, measures. But the works of Vitruvius and Hieron essentially are highly technical documents. They explain in detail not just how to replicate existing machines, but they also explain the fundamental principles behind such machines, meaning that it's one thing to copy, but they explain how things work, which means you can then tailor-make your piece of equipment to your need. You can scale it up, you can scale it down, you can turn it from a pulling machine into a lifting machine, and in their works, Hieron and Vitruvius, very technical, and we see the legacy of them in later machines such as Da Vinci's pit. Now even Vitruvian Man, it's named after Vitruvius. It's a illustration of a description in Vitruvius' 10 Books of Architecture, talking about man is a measure of all things and proportions, and how systems of measure are based on an idealized human form. But Da Vinci, he didn't really invent these things. He directly copy-pasted them and rewrote them down from these earlier works from Vitruvius and Hieron. Now, for instance, Hieron talks about how to lift weights and to use compound pulley systems, and we can see this is thanks to Ninth Heretic, she visited a Da Vinci exhibit, and now this one, you just have one more beam there because that's going to be now lopsided. But okay, all you got to do is add one more beam, and you got a solid lifting frame. And again, the Romans and Greeks didn't just use that crane with an extended arm. They also used hoist cranes, which are much stronger, much better at lifting very heavy objects. The hoist crane is a good mobile type of crane. It's like the crane you see going down the road with that extendable arm. they're good general purpose cranes, but they're not good for lifting very heavy weights. It's good for lifting a pool from your front yard into your backyard. It's good for picking something up and moving it over there. But any extendable hoist boom arm with that big arm extending out, that's the worst type of crane for heavy lifting. It's good for practical, convenient purposes, but these types of cranes are the ones that in antiquity and still that they use now in engineering works, engineering shops and big construction. They'll build a hoist crane, not a extendable arm crane. Again, the weapons, siege warfare, Heron and Vitruvius describe these things, and in many ways they are better than Da Vinci's depictions because they're using a torsion spring, much easier to tune, much easier to repair, much easier to build, much easier to maintain. Heron of Alexandria, steam power to make automatons and open doors. So doors would automatically open to temples with steam power, and then he would use that same steam power to blow into horns like a pipe organ, and they would actually play music as the procession entered the temple. All you had to do was light a fire, and then the systems took off. Automatic steam-powered doors and music, or essentially, like when I was a kid, we went to Disneyland or one of those theme parks where you have the automatons, the animatronics, and in his published work, so he describes, as he wrote a book on pneumatics, on automatons, and also the mechanics of lifting simple machines and how they can be applied to lifting heavy weights as well. That was published. Now in Vitruvius, again, he speaks of the same thing. I think it's book 8 or book 9, talks about these machines, and the famous Antikythera mechanism also from around about that time, the exact date and place of manufacture, but it's in the Greco-Roman period. It was a computer. There were 4 competing calendars at that time. The Antikythera mechanism was a computer that could adjust the date to these different calendar systems, could also predict the positions of sun, moon, planets, the zodiac over 200 years in the future within the accuracy of if you were to hold your hand out in front of you, the width of your thumb, that's how far the moon would be away 200 years into the future based on the Antikythera mechanism. Heron worked at the Library of Alexandria, the storehouse of knowledge. So previously it was Heliopolis was the hall of records where they kept the royal records and the centre of astronomy and astronomical measures, and the sciences, geometry for instance, philosophy as it was called, natural philosophy, and then it moved to the Library of Alexandria, the Ptolemaic capital. They moved it to there. That's where Heron worked, and Eratosthenes also worked there, measured the circumference of the earth, some fantastic astronomy. Later Romans would have just a brilliant level of distances, and even took the Babylonian astronomy one step forward. Very, very accurate. So Vitruvius and Heron were Heron literally worked in the Library of Alexandria. Vitruvius had, prior to Heron, had access to that knowledge that was being disseminated from places like the Library of Alexandria and Heliopolis as earlier Greek-Roman writers. This was the transfer of knowledge from Babylon, Chaldea, as well as Egypt to Greece, and then from Greece to Rome. And the Romans were also very interested in these other parts and learning from these other parts of the world. And so we have these super heavy. Now, any other place in the ancient world, if these stones were moved, this would fit into they're megalithic, but there is a curious silence in regards to these things. So not only did the Romans move these Egyptian obelisks, they moved them much further across much more difficult terrain. This is also part of the transfer of knowledge. And this knowledge would be resurrected during the Renaissance, and so that the obelisks in Rome would be either relifted or brought down and then moved within Rome. Well, again, for instance, the famous Lateran obelisk, it was toppled, part of the bottom part was broken, the part still exists. There is a plate was on the plinth to even show how the Romans did this, but Da Vinci, who read the books of Vitruvius and Hieron, he was of that same era and using ancient technology. This was pre-modern technology, so it's still ancient. They were able to lift and move these obelisks. And of course, Egyptians actually had cattle, so sometimes you'll hear, oh, how did the Egyptians do it without animals? Well, actually had animals from prior to year zero, but with rope and red cedar being the only tools necessary for these. Now, the famous red cedar of Lebanon, you can find that in Old Kingdom Egypt. There was trade, and they were moving because that type of timber just doesn't grow on the Nile Valley. It had to be imported either from further down in Africa or from places such as current-day Lebanon and the red cedar there, which back in those days the forest would have been even larger. That's one of the reasons for deforestation. More than likely, Epic of Gilgamesh hints at that there was probably, even on the Tigris Euphrates, there was more trees, but to build the cities and do all these type of construction projects, the canals and other things that they built in very long time ago, it was deforestation. But this important timber and red cedar was still imported, was almost a sacred timber into the Roman times as well. So based on the older writings, the era of Da Vinci and Pope Sixtus V moving these mighty obelisks, megalithic, if records didn't exist of these things of how they did it, that would be part of the mysterious megaliths, but they're not mysterious because, again, they're very well described, the techniques for their, not just replicating the machines, but they understood the principles, and that's the most important thing. It wasn't just making something that you've seen made and making an exact copy of it. They had the knowledge to tailor make their equipment to their needs. And of course, ancient Egyptian rope as well, very high quality. Actually, you can go back to Neanderthal times. Rope has been a very important part of technology, rope making. So through the Library of Alexandria, Hieron, and even prior to him, Vitruvius, these writers. And so, for instance, moving this massive, the Lateran obelisk, for instance, in the 1500s. Now, even then, so this is a famous, the wall of the Baalbek temple complex, and there are 7 large stones beneath them. Now, some high-profile researchers who have been at it for quite some time, I do believe in the last year they've changed their tune, but they would often say that using ancient technology it was impossible to move these 7 stones underneath, weighing about 350 tons. Well, that's just not correct, because actually it was possible, it was done. And then we have the trilithons above them, weighing from anything from 850 to about 1,000 ton. And again, this single lifting tower, so the original Roman one, this is a picture diagram from the 1500s, but again, literally based off old Roman writings, to lift a 450 ton Lateran obelisk originally, which was transported from Egypt, no less, and then up very difficult terrain, much further than any of the terrain that the other prior people had moved these stones. But the trilithons, using, just by adding a lifting tower, you could lift them using that technology. So they could have done it in the 1500s based on the same ancient Roman technology. And the Romans, although it's not clearly spelled out for us, since they inherited geometry, astronomy, arithmetic, just natural philosophy from Egypt and the Tigris Euphrates, did they just, Roman tech just pop up out of the ground? Did they not need to employ some other method? Why could not previous civilizations to the Greeks and Romans have the same level of physics? They had the same materials. Seems strange. But so Greeks and Romans unashamedly tell us that they learnt their astronomy, geometry, philosophy, with general term for science, timekeeping, calendars, weights and measure systems inherited from these older civilizations. And it seemed, now there are again some who would either ignore, which is one thing, but then there are some who make definitive statements that the Romans could not do these things, when this is absolutely false. Now, if you make a statement that they could not do it, that implies that you understand something of what they could do. And if you make a statement based on that, well, there's some choice words for that, and I just find that very curious that there is if you bring up this knowledge, this fits in with certain narrative, and it will be accepted, not only accepted, celebrated, but the mention of technology and engineering and survey is very strangely lacking. So, for instance, Plato's description of Atlantis, by Plato's own description, was a third or fourth hand account off a much older story. Now, this is accepted, or should be accepted, as literal, and I'm not saying it should. I think there's a very interesting piece in there. We need to be looking into our ancient past with open eyes. However, I think it's a very important point that there are technical first-hand descriptions such as Vitruvius and Hieron, and the moving of these massive obelisks, and they are strangely missing, especially combined with the fact that the achievements were there. They told us how they do it, and it's like literally there to be seen. We know that these obelisks come from Egypt, even if they're replicas of Egyptian obelisks, which, well, they're not. But even if they were, well, the technical aspects of it should be considered and at least celebrated. Not even at least considered and mentioned, as where the problem is that they are diminished or dismissed, and false facts are inserted about Roman capacities. But where did the Romans learn from? Now, the Romans and Greeks understood physics. Why is it impossible that earlier people could not understand the same physics, given that they were working with the same materials? So Greeks and Romans learnt so much from earlier civilizations. The temple build, just for instance, the Parthenon, just outstanding piece of engineering. In volume, not the same, but in technical aspects equal to it, and in many other ways superior, because of the Pantheon in Rome is another example. It's not heavy, but that adds to the engineering of it. It's a hollow building, and the actual center point of a building floats in midair. And that's where we have to consider. So geometry, astronomy, calendars, timekeeping, measures, imported from previous civilizations. Surely engineering, unlike these other aspects which are clearly told to us that the Greeks and Romans imported them, so why not engineering? And also survey, and that's an interesting point, because the Great Pyramid is an example of this, of the high skill level of surveying. So it's one thing to build, but you have to be able to survey that. That's a very important feature of engineering. It's aligned to true north within 0.05 of 1 degree. Now, it might actually be they intended, because of the method, to find, okay, that's another technical issue, but it could also be that this is 0.05 degrees was an intentional aspect. But let's so again, to it'll also be said that the pyramid was the highest building until maybe the 1800s. Well, actually, Lincoln Cathedral in the 1500s, a little bit earlier, was higher, but that's neither here nor there for the moment. But so the alignment of the pyramid to this high degree of accuracy, but again, was this accurate? So surveying techniques, were they also inherited from previous civilizations, especially the Egyptians? Well, yes, they were. So we have the aqueducts. If you take the volume of these aqueducts and put them together, they compare with any other structure. So they're just stretched out over a large distance. So 100 feet or 30 meters high for 9 miles, 14 kilometers. You pile these stones up, and you're going to get something really big. But this was just one of a series of aqueducts built in a very short time, which included mind-bogglingly long tunnels, again carved with a high level of accuracy. And by I mean high, I mean 1 in 4800 or higher. And what is that? That's here's just a list of the obelisks, their underground portion, total length, underground portions, just amazing stuff. And really, it's not celebrated as much, I find mind-bogglingly curious. So at 1 in 4800 is 0.0119 degrees, and that is high, much significantly higher than this extraordinary level of accuracy found in now the Great Pyramids, a special example, but in other pyramids it's actually they don't reach anywhere near that level. And this was done through the air, mind you. So these aqueducts were carved tunnels, and they had to keep the level straight, because if it was a slight bend, the water would pool up and dam, and to keep the water moving, it had to be not only at that level, but consistently at that level over distances nearly 100 kilometers. Absolutely extraordinary. Pont du Gard, that's 37 centimeters for every 1 kilometer. That's higher than 1 in 4800. Just now again, these were described in Vitruvius. He describes this angle being required, and just the physical evidence of it is there as well. But he also describes the survey tools used to that. Hieron also mentions survey tools, and the Roman surveyors were held in high esteem, and the tools such as the grommer, well, that's actually Egyptian. And these other tools using the plumb line, now that also counts for a pendulum, which we use for timekeeping. But so the Egyptian surveying tools and surveying methods and the accuracy that they were able to achieve in their temple layouts was also an inheritance to the Greeks and to the Romans. It's exactly the same. Now, they might have invented it on their own, but with all the other geometry, astronomy, timekeeping, Greeks and Romans said they inherited it from the Babylonians and the Egyptians. And well, it would be extraordinary coincidence that they also developed the same surveying tools. And you can find these written in the works of Hieron, and you can find them written in the works of Vitruvius, and you can find the physical examples across the Greco-Roman world, and we can find the physical examples of this survey, this high level of accuracy, also in Egypt, Babylon, Chaldeans, and the weights and measure systems as well, and that both Old Kingdom Egypt and the weight systems of Sumer, Chaldea, correspond so wonderfully to Mohenjo-Daro and the Indus civilization of Harappa. Well, anyway, so Greco-Roman world inherited so much of their knowledge from the Tigris and Euphrates, and not to include, or at least to consider, that the Roman way of lifting and moving obelisks and surveying was not also inherited from these other civilizations. I find that, again, a little bit curious, especially the silence in regards to these things, and I find actually more than curious that certain people will actually diminish or say 100% wrong things about the Romans. It's one thing to express your opinion, but to make definitive statements that they could not do this when the records and the extant monuments are actually there and clear, that I find very, very curious. I find that suspicious. But from Heliopolis, from Egypt, and from and Nineveh and these other places, for instance, the Hanging Gardens and the use of water moving technology, Archimedes screw, well, there's lots of evidence to show it was actually, again, from the Tigris, Euphrates, and even the movement of water, which aqueducts were so important for. Well, the very famous Egyptian polymath Imhotep, amongst his many achievements, was also his ability. Now, they describe it in different ways, but essentially they're describing irrigation as well. And this is another important reason. If you can harness water, you can harness irrigation, you have a civilization, and that's what these great civilizations were able to do. And in many cases they left, well, records are very clear, very interesting. I hope you found this educational, interesting. Vitruvius, Hieron, Herodotus, look them up. Lots of records come from